Have you ever explored whether we're truly alone in the universe? Or, then again, have you expected that there's something else to our world other than anything that we see? Envision what is going on. Think about how conceivable it is that the James Webb Space Telescope will finally show that we live inside a dark hole. Join us as we sort out more about this world, spreading the word that will make you question everything you thought you knew about the universe. So, what exactly are dark holes? They're like something out of a spine chiller. Sure, you might have seen them in sci-fi films, but what's substantially more disturbing is that they're not simply a made-up idea. As per well-informed experts, dark holes in space are truly enormous amounts of matter pressed into an incomprehensibly infinitesimal area. Imagine a star a few times more massive than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Scientists have been hypnotized by dark holes for a long time. At first, they concentrated on objects in space so huge and thick that they could trap light. The most striking ideas about dark holes were proposed by Einstein's theory of general relativity. Basically, when a gigantic star dies, it leaves behind a thick core. If this core's mass is a few times that of the Sun, gravity overwhelms everything else, leading to the formation of a dark hole. It isn't simple to detect dark holes as they emit no light. However, analysts have found ways to interpret their presence by observing their effects on neighboring matter. For instance, if a dark hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Moreover, when an ordinary star gets too close to a dark hole, it can be destroyed, producing X-rays as it does so. Dark holes also have a huge influence on their surroundings. They can consume nearby stars, produce extreme light emissions, and even influence the formation of new stars in certain regions, while stifling it in others. So, how do dark holes form? Picture this. Stars, once brilliant and shining, meet their fiery end in a massive explosion called a supernova. From the remnants of these fallen giants, dark holes emerge. Most dark holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is a few times the mass of our Sun, it collapses under its own gravitational force, forming a dark hole. As these giant stars collapse, something astonishing happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time appears to slow down near the event horizon, the last defining point for anything falling into a dark hole. The clock ticks at a different speed compared to ours on Earth. Occasionally, when two smaller dark holes collide, they merge to form a much larger and even more frightening dark hole. If a dark hole interacts with a neutron star, it creates an unbelievable nightmare that defies understanding. Scientists have been grappling with the size of these cosmic anomalies for quite a while. Dark holes come in two sizes, big and small. However, there's a bit of a misunderstanding about them. Small is relative when it comes to dark holes. Very large dark holes, remnants of gigantic stars, can be as much as 10 million times the mass of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That is a colossal number of dark holes that could swallow anything in their path. But wait, there's more. Extremely large dark holes exist at the extreme end of the spectrum. They are millions, if not billions, of times larger than the Sun. These inhabit the centers of massive galaxies, including our own Milky Way. They appear like a massive dead space, pulling everything toward them. The renowned physicist Stephen Hawking discussed dark holes throughout his life. His theories were well established, but some of his ideas proved difficult to confirm due to a lack of advanced technology. However, there is now hope on the horizon, not too far off. A single revolutionary instrument that is changing everything. The James Webb Space Telescope, JWST. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a demonstration of human ingenuity. Sure, we've launched other space telescopes before, and they've done their jobs competently, but this extraordinary machine is on a level that is truly remarkable. The JWST makes the Hubble Space Telescope, which has served us for so long, look like a basic tool. The retail cost of this enormous wonder is a staggering $1 billion. Yes, you heard that right, an eye-watering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with enormous contributions from more than 300 universities. However, we shouldn't forget the risks associated with such a grand undertaking. I understand that this isn't a venture for the faint of heart. The JWST is venturing into uncharted territory, expanding the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several groundbreaking accomplishments. It traveled more than 1 million miles to reach its orbit around the Sun, where it will live indefinitely. During its journey, the telescope successfully deployed its massive 5-layer sunshield and enormous primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after alignment and adjustments, the telescope is nearly ready for full operation. One of the most exciting parts of the James Webb Space Telescope's mission was when NASA reported that it had captured its first significant images of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 dispersed brilliant spots from the star's light gathered by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory adjusts the individual segments of the primary mirror, it will begin the process of stacking images on top of one another to create one clear view. Thanks to its cutting-edge technology, the JWST will help scientists study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge once again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are incredibly challenging to detect because of how they interact with their host stars. Observations can now closely study these planets, allowing scientists to analyze their atmospheres and explore the conditions necessary for life. The JWST's capabilities will help researchers better predict whether specific planets may be habitable. Past studying planet formation, scientists focus on these worlds to understand how matter is organized on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the worlds we see today, billions of years later. One of the JWST's objectives is to look back at the earliest galaxies to better understand how they formed. Scientists are also trying to determine how we got the variety of galaxies we see today, as well as the ongoing processes that lead to the formation and merging of galaxies. To unravel, the James Webb Space Telescope, JWST, is certainly at the forefront of this exciting scientific journey, with its ability to observe distant galaxies, stars, and even exoplanets in unprecedented detail. It has already provided a glimpse into the depths of the universe and has shown that we may not be as alone as we once thought. One of the most mind-boggling revelations from the JWST is its ability to detect molecules such as polycyclic aromatic hydrocarbons, PAHs, around supermassive black holes in galaxies billions of light-years away. These organic molecules, which could potentially be the building blocks of life, are found in dense gas clouds near black holes, hinting at the possibility that life could exist in places that we previously thought were inhospitable. The fact that these PAHs can survive near black holes, where the gravitational forces are extreme, further fuels the idea that life might not be restricted to just one corner of the universe. Moreover, the JWST has also uncovered the most ancient black holes that date back to the dawn of the universe, just 570 million years after the Big Bang. These early black holes are not only massive, but their discovery challenges current theories about the formation and growth of black holes in the early universe. Astronomers now speculate that there may be even older black holes yet to be discovered, hidden deep within the cosmos. In addition to investigating black holes, the JWST is providing valuable data about the formation of stars and galaxies, shedding light on the processes that led to the cosmic structures we observe today. It is also enhancing our understanding of exoplanets and their potential to host life. By studying the atmospheres of exoplanets, scientists can now identify the presence of gases such as water vapor, methane, and carbon dioxide, key ingredients for life as we know it. The telescope's infrared capabilities allow it to detect faint signals from these planets, even those that are light years away, helping to answer the age-old question. Are we alone? These groundbreaking discoveries also bring us closer to understanding dark matter, a mysterious substance that constitutes a significant portion of the universe's mass but remains elusive to current detection methods. Some theories suggest that primordial black holes, formed shortly after the Big Bang, could be responsible for dark matter. If this theory holds true, it would open up a new avenue of research into the very fabric of the universe. As the JWST continues its mission, it will undoubtedly revolutionize our understanding of the cosmos. The possibilities it opens are vast, from uncovering the origins of galaxies and stars to exploring the potential for life beyond Earth. Each new revelation will bring us one step closer to solving some of the universe's most profound mysteries, ultimately helping us understand not only where we come from, but also whether we are truly alone in this vast, mysterious universe.